Welcome to NetWitness 12.4 New Features Training. In this video, we will discuss the updates in decoders and log decoders regarding parser utilization. Here, a Google Chrome window is open with the REST interface for a decoder. Note that all the explained concepts in this video are applicable to live decoders as well. The only difference is that the parsers between the two devices differ, and even within the devices as well, which is discussed later. To start, let's go to the parsers config folder and check detailed stats. Detailed stats is disabled by default because the footprint that comes out of detailed stats is pretty large, both on the serialization as well as processing front. If we go back to the parsers folder, you notice that the definitions folder is now exposed. Previously, detailed stats had to be enabled to expose the folder as well as the folders within it. However, to add some more insight into parse serialization, the stats within these folders were exposed to leverage that information. So, if I go down to the definitions folder, we have all the parsers, such as the feed parser and the HTTP parser. Let's, for example, check the HTTP parser. Starting from version 12.4, without being gate-kept by detailed stats essentially, the folders within definitions as well as several stats for each parser are exposed. The selected ones are the stats that map to an util value. The others are more descriptive, but for utilization purposes, these are the stats we will use. As you can see, we're exposing memory usage as well as callbacks and callbacks counts for meta, ports, and tokens. This applies to any parser. So, a similar case applies to other parsers, such as the feed parser. Let's go back to HTTP and pretend that some traffic is being ingested in the background. After packets are sent, if I refresh this page, you notice that the token callbacks count went up. This is the general idea, an insight into how the parsing work is done on a decoder. Generally, it is hard to diagnose. Previously, we had to enable detailed stats and check the individual stats for each parser. Now, by exposing just a little bit of information on the parser by default, even without enabling detailed stats, we can better troubleshoot a situation where, for example, during a specific time period, identify which traffic is using the most resources. Let's say that over the workday, from 9 to 5, we see that the HTTP parser uses a high amount of memory compared to all the other parsers. So, that's why exposing this information is beneficial in such situations. As far as how it's ultimately serialized, if I go back to parsers config and locate parser.stat, we can see that we started housing them in a whole new directory, parse.db. To avoid any inconsistencies in prior configs, the stats that are exposed in the definitions folders are already being rented as sys.db, the original stat.db. However, if the end user chooses to configure it so that those stats don't get written, they can access those stats here, in parse.db. Let's now check each of these config nodes. Parser stat compression is just which compression algorithm you like to use when writing to the parse.db. Parser stat dir is the actual location of the folder on the file system. So here, it's just C, NetWitness, ng, decoder, parse.db. Parse.stat exclude is a list of what stats to not serialize to the database. By default, it's configured to not write the descriptive stats, such as the description for a parser. This applies to any subset of parsers and/or any subset of stats under those parsers. So, if you choose to serialize any of them, you can do that here. Parser stat interval controls how often the stats themselves get updated. So, as indicated earlier, detailed stats is expensive. To compensate for that, we selected a subset of stats to be exposed, and we controlled how often the stats are updated in the tree. The only restriction for the interval is that it cannot be faster than the original interval. This denotes how often the milliseconds to update the stats. Let's now go to the parsers node again. As far as querying it from a client perspective, the stat.hist call is added to decoder parsers, where it essentially works the same way as the original sys status, but it specifically queries the parse.db. So, If I enter no parameters to get the balance for the database, then take time 1 and time 2 to get a rundown between them, the stats that were serialized appear. So, we can see that the FTP parser used this much memory usage. The feed parser used this much memory usage. When we scroll down a bit, you can see that mail generated this amount of token callbacks during that time. This is the mechanism for querying the parse.db. Since the original StatDB is still housing these stats, any prior client application that leverages something like the sys telemetry, as well as this original sys status, are still applicable. Finally, there are plans to expand on this change set, such as adding more stats or tuning the client infrastructure. Thank you.